Okay, before we begin, the first thing you need to know is on Edline, under the notes folder, there is a page of notes that goes along with the notes that we're getting ready to do right here, right now. If you want to go get that, you can. If not, you can take them on your own paper. It doesn't really make a difference. I'm just letting you know it's there. So if you would like to, you can pause, go get that, and then come back. So we're going to solve systems using graphing, which is the easiest method that there is. So we're going to start by graphing by hand. So we have these two equations, y equals x, y equals negative 2x minus 3, and we're going to graph them both on this little graph right here. So y equals x has a y-intercept of 0 and a slope of 1. So there are my points. I'll connect them with a line here so you can see. How it looks. And then the second one has a y-intercept of negative 3 and a slope of negative 2. So I've got to go down 2 over 1, or I can go backwards and go up 2 to the left 1. And then I'll connect those with a line. And you can see that the two lines intersect right here. And so the solution to this system is that point where they intersect, which you can see is negative 1, negative 1. So my solution should be negative 1, negative 1. But we're going to pull out our calculator, and we're going to use our calculator and check the table and see if that is really what it is. So here is our calculator. We're going to go to y equals, and we're going to enter in the two equations. The first one was y equals x, and then the second one was negative 2x minus 3. And if I were to graph it, you'll see there's extra stuff on my screen that's going to cause a problem. But you can see there's the two equations that we just did, but that's not what we want to look at. We want to go look at the table. So if you go to second and then graph, it'll pull up the table. And if you'll look and scroll through your table, you should be able to see that when x is negative 1, y1 and y2 both are negative 1, and so that's equal. Both y1 and y2 are the same thing. That means that's the solution. So we're going to use this table to fill in the table on our notes. And so we're going to do negative 2, negative 1, 0, and 1, and we're going to fill in what it says on our table over here. So when x is negative 2, y1 is negative 2, and y2 is 1. And so over here, this is negative 2, and this was negative 1. We already saw that at negative 1, it was negative 1 and negative 1. And then when you look at 1, it's 1 and negative 5, and then at 2, it's 2 and negative 7. Need to correct that. This should be a plus 1. So this is 1 and negative 5, and this one becomes 2 and negative 7. And so if you look, this section right here in the table, it's the fact that y1 and y2 are the same. X being the same is coincidence in this case, but when y1 and y2 are the same, that points to your solution in the table. And that's one easy way to get the solution without actually having to go do elimination or substitution. Let's do another one. So we're going to use a table to determine if this ordered pair is a solution. So we're going to check to see if this ordered pair really works, but I can't do anything with these yet. They've got to say y equals. So this first one, 2/5 x minus y equals 0, I need y to be by itself. So I'm going to solve this for y. So I subtract 2x, or 2/5 x, and then I'm going to have to change all the signs so I have a positive y. So there's the first one. And then the second one, which is 3x minus y equals 13, I subtract the 3x, so I get negative 3x plus 13. And then when I change all the signs so I have a positive y, I have 3x minus 13. And so I'm going to put both of these in my calculator again. So we're going to go back to the calculator. to go back to y equals, and we're going to enter in those two equations. The first one was 2/5 x, so I have 2/5 x, and then the second one was 3x minus 13, so I have 3x minus 13, and we're going to go back to the table. So that's what we want to look at, and we're looking for this point right here, 5, -2. That means x equals 5, or 5 positive 2. X equals 5, and then y is 2. And if there's a solution, then when I get to the 5, both of these should say 2. So we're going to go look at our table, and you'll see right here at 3, y1 is 1.2, but y2 is -4. So that's clearly not the solution. If you look at 4, y1 and y2 also aren't the same. But when you go to 5, if you look at 5, y1 is 2 and y2 is 2. That means that the ordered pair 5, 2 is going to be my solution because these two are the same. So let's write down what we have. At 3, it was 1.2 and -4. At 4, it was 1.6 and -1. And then at 5, they were both 2. And then just to finish it out, because it makes me feel better, at 6, we have 2.4 and 5. And so here at 6, this one's 2.4 and this one was 5. You'll notice right here, the y1 and y2 column were exactly the same. So yes, this is a solution to the ordered pair. Yay! Okay, next one. Mr. Lone's putting money into 2 savings accounts. He's modeled the amount in each account over 40 months on the graph below. So we have the graph already. The question is, based on the graph, what will be the balance when the 2 accounts have the same amount? So I'm looking for where they are equal. Well, they are both equal right here where they intersect. We're looking for the balance. If you'll notice, balance is over here on the y-axis, and so the numbers are very, very hard to read, but it looks like 1, 2, 3, 4, 500 right here, and so the balance is going to be $500 when the 2 accounts have the same amount. If you really want to know, it's also going to take 4, 8, 12, 16, 20 months to get there. I know that wasn't part of the question, but it doesn't hurt to go ahead and see it. They will have $500 when the 2 accounts are equal. All you're doing is looking for the intersection point. Okay, the next slide that I'm going to show you gives you directions on how to use the calculator for the next part of what we're going to do. You can either pause and write this all down, or you can just follow my keystrokes as we go through with the calculator in just a second. Or you can, like I said, go to Edline, print off that little page, because this is also on that page that's on Edline. But this tells you how to walk through the calculator to get the calculator to solve a system for you. Yes, that's right. The calculator will do it for you. So number 5 here, I have a system of equations. I have y equals x minus 16, and then y plus 1/3 x equals -1. You cannot have the calculator do this for you if they are not both in slope-intercept form. So both of your equations have to be in y equals form. So this first one, I'm going to have to get y by itself. So I'm going to subtract 1/3. So it becomes y equals -1/3 x minus 1. And then my other equation, this one right here, is already in y equals. So we're going to use our calculator. So we're going to go back to our calculator. And we're going to go back to y equals. And we're going to enter in those 2 equations that we just came up with. So the first one was x minus 16. So I'm going to enter in x minus 16. And then the second one was -1/3 x minus 1. So then I have -1/3 x minus 1. We're going to graph them and see what they look like. Now the first thing that you need to look at is the fact that you cannot see where these 2 equations cross right now. If you can't see it on the screen, then your calculator is not going to be able to find it either. So we're going to have to change our window settings or our zoom in order to see this. Let me turn on my axes so that we can actually see them. Make this a lot prettier. But we're going to have to zoom so that we can see where these two lines intersect way over here somewhere. So I'm going to push the zoom button, and I want to zoom out. So I'm going to hit number 3, and I'm going to move my cursor over in the direction of where I want to zoom to. So it's going to be over here to the right and then down a little bit. That's probably good. And if you hit enter, it will zoom out. Now I can see where the two lines intersect. So now I can find the intersection because the calculator can see it, and so can I. So here's how you find the intersection. You're going to press second, trace. You get this pretty menu. Guess what? We want the one that says intersect. So number 5 says intersect. And we're going to hit enter 3 times. It should say first curve, enter. Second curve, enter. Guess, hit enter again. It should say intersection at the bottom. Once it says intersection at the bottom, you have gotten to the solution. So there's our answer, 11.25 and negative 4.75. So this is where those two lines cross. So when I write down my answer here, my ordered pair is 11.25 and negative 4.75. And yes, the decimals are fine. But instead of having to go through elimination or substitution, my calculator took care of it for me. So let's try the next one. They both already say y equals, and I'm pretty sure we're going to round this one to the nearest tenth. Sorry, we'll round to the nearest hundredth. We'll go to 2 decimal places. I believe that when we do this, it's going to get really nasty. But if you'll look, the second one is already solved for y for us, so we're going to leave this like it is. But the second one, we're going to have to get y by itself. So we're going to add 1.6x, so y equals 1.6x minus 5.34. We're going to do the same thing. We're going to put these into our calculator. So we're going to go back over here. We're going to go back to y equals, and we're going to enter in our new equations. The first one was 4.7x plus 2.1, 4.7x plus 2.1, and then the second one was the 1.6x minus 5.34. Now, when we graph this one this time, it's going to graph in the same window that we graphed the last one in, and I don't want to do that. I want to graph in a standard window. So before I graph, I'm going to press zoom, and then option number 6 says zoom standard. That takes us back to a standard window, so I'm going to choose option 6 to graph. That way I go back to a standard window. And you'll see, you can just barely see the intersection point right here, but you can see it, so your calculator can find it. So we're going to go second, trace. Again, we want option 5 for the intersection. We're going to hit enter 3 times. You can't do this real fast. You can't go enter, 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 and hope it does. You have to take your time. So you enter, enter, and then enter. Make sure it says intersection at the bottom of your page. These don't have long, nasty decimals, so we'll just leave them like they are. So negative 2.4 and negative 9.18. So my solution to this one, negative 2.4 and negative 9.18. You could have done this using elimination or substitution, but with all those decimals, who wants to mess with that? So now we know how to use the calculator to do it. So let's do one more. Or 2 more. Okay. Neither one of these is solved for y, so that's step number 1. You're going to have to get y by itself. So in this first equation, you'll subtract 4x. So you have negative 2y equals negative 4x plus 4. Then you have to divide by negative 2. Don't forget to divide everything. So y is going to be 2x minus 2. So there's the first one. The second one, I'm just going to have to divide both sides by 2 so that y equals 2x. Now, if you will look at these two lines, the slope of this one is 2 and the slope of this one is 2. So that should tell you that these lines are parallel. If they are parallel, they aren't going to cross. And since they do not cross, this has no solution because they are parallel lines. If you just have to see it, you can go plug these in your calculator and graph, but you should see they don't cross. So there's no solution. Okay, last one. This one asks for the x-coordinate of the solution to the system. All they want is the x-coordinate, and they say round to the nearest thousandth, which is 3 decimal places. So, you know, make sure you round to the right place. So we got to solve for y. This first equation, subtract your 4.8. So you have negative 4.8x plus 4, and then you have to divide by 0.6. And yes, I'm going to use my calculator to do this, so there's no making fun of me tomorrow because I used my calculator to do simple division. So this one right here becomes negative 8x. And this, we're going to leave this. I apologize because this comes out to a decimal. We're going to leave this as 4 over 0.6. I realize that's kind of an icky number, but if you actually divide it, you get a repeating decimal, and we don't want to go there, so we're not. So the next one, let's get y by itself. You're just going to subtract the 3.2x. And then we're going to go put both these in our calculator, and all they want is the x value. We don't care about the y value at all. So we're going to go over here. We're going to go back to y equals, and the first one is negative 8x plus the 4 over 0.6. So we're going to do plus 4 over 0.6. And I think I'm going to go put this in parentheses because it'll just make me feel better. I don't think you have to, but it makes me feel better, so I am. And then the second equation was the negative 3.2x plus 2.7. So I have negative 3.2x plus 2.7. And graph them. We're still in a standard window because it was in a standard window when we graphed a minute ago, and you can see right here is where they intersect. So again, we're going to go find the points. We're going to go second trace, number 5. We're going to hit enter 3 times. 1, 2, 3. And here it tells me the intersection, and ooh, we get these big, long, yucky decimals. Guess what? If you just solve this with substitution or elimination, you're still going to get big, long, yucky decimals, or you're going to get some weird little fraction. It's said to round to the nearest thousandth, so we are. So this becomes 0.826, and that's all they want is the x value. So you're going to say that x equals approximately 0.826, and you're going to leave it at that because they did say they just want the x coordinate. That's solving by graphing. You're just trying to find the point where they intersect. You can use your calculator, or if someone's nice enough to give you a graph, you can just look at the graph and pull it from there. So I will see you guys tomorrow. Have a good rest of your evening.